Thanks very much for this nice introduction, Nurit. Welcome to this presentation. The title of this presentation is the ETSI Zsm Framework Architecture. So based on the talks that we heard before, I would now like to zoom in on the architecture that we are currently developing in ETSI Zsm. There were many words of motivation said already, so I want to focus on two things and recapitulate them before going into the architecture. The first one is the topic that we're adding complexity to our networks currently. We're adding software-based technologies, we're adding virtualization, we're adding things that we know from the world of web scale. These things bring us the possibility to become quicker, to evolve faster, to become more agile, but also, of course, when looking at network management, introduction of these technologies requires that network management has to keep pace with that agility. So we can't any longer use a one-size-fits-all solution, but we need a flexible, or we need the possibility to compose management services as flexible as we can compose the actual network services. Also, taking such approach, such service-based approach, allows us to decouple the speeds of evolution, because there may be areas in the network, domains in the network, that develop at a rather moderate speed. Others will develop faster, and we have to be able to decouple those areas to be able to manage the whole complexity that we have built into our networks, or that we are building into our networks currently. The second topic is also that these technologies increase TCO. So complexity comes at a price. And management complexity, of course, if we would do it manually, like we did in the old days, this complexity, this scale would increase the cost of management. And the response to that is automation. And, well, Zero Touch in ETSI tries to address these two challenges. First, by laying the foundation to provide flexibility. And then second, by looking at how we can leverage this flexibility to enable automation. So in ETSI Zsm, when we started the architecture work, we discussed about how do we name the thing that we're actually specifying. Is it the ZSM system? This is what we started with. And there were a lot of discussions basically leading to us realizing, no, this is not the ZSM system that we're specifying a framework, which we call the Zsm Framework. The Zsm Framework has a few key properties. First, it consists of management services, which can be composed. So service composition is a possibility there, or a basic principle. Services are exposed, and they can be integrated, and the architecture, the framework architecture has to provide means for that. Interfaces will be model-driven. They will be open. Well, being model-driven allows to be open one way or another. You could standardize them fully, or you could provide means to describe what's in the interface, so to provide the models. Because on the other hand, you can probably not standardize everything. Otherwise, you will slow down innovation. So standardize what's necessary and enable what's possible. Also, intent is coming into the game. Certainly not every interface in the framework will be intent-based. For instance, an interface towards a resource will typically still consist of a bunch of parameters. But others, higher-level interfaces, are good candidates to be intent-based. So you just specify the intent, and then the system resolves the intent to parameterization, to workflows, to what is needed. Looking into the future, we're not there yet, but this is where we want to go. Separation of management concerns is quite important. I mentioned that we have to decouple the evolution speed of different parts of the network. It helps, this helps with that. Also, we have end-to-end services, we have network domains where we manage the resources, and these are also two different concerns that we need to decouple, that we need to connect by service-based interfaces. Furthermore, to drive automation, we need data. If you don't know what's going on in the network, you cannot make decisions, you cannot automate. So we need to be able to provide access to stored data. We need to be able also to stream data, to provide rapid information, rapid updates to the components involved. And last but not least, we need to enable closed loops in the system, in the framework, to basically allow automation. And, well, we're currently building the architecture with that in mind, and we hope to arrive at a solution that allows deployment flexibility and that is open for rapid evolution. This shows the current status of our work. As I said, it's work in progress, it's ongoing, so it's a snapshot, subject to change. But I think it pretty well illustrates where we are going, and we're more going into details, I think, than fundamental changes to that picture. What you see here is this dashed box. It gives the scope of the ZSM work. So this is the ZSM Framework Architecture. At the bottom, we have resources, network infrastructure resources that we're managing. These somehow communicate with functional components which we don't standardize. We don't standardize the components. We only standardize the services which they expose. And we have management domains. We have the end-to-end service management domain that can work cross-domain. And we have a few other things that I'm going to go in depth in the next slides. At the top, as a consumer, we have a box that we call the digital storefront. These could be processes that are also automatic, that automate the operator's business processes. These could be self-service portals. These could even be interfaces to external value-added resellers or business partners that provide value-added services on top of the network slices provided by the network operator. And this is basically out of scope of ZSM, as well as the resources. So we're just interfacing with the resources. Let me now run you through a few basic features of the architecture that were built, driven by the principles that I introduced at the beginning. The first one we called separation of concerns and management. And that means we have two big scopes of management. One scope is the scope of a management domain or network management domain. This is a scope that is delineated by a certain boundary. Boundary is deployment specific, could be organizational, could be technological, could be other criteria like geographical or even a combination of those. A management domain manages network resources and it manages services that are based on those resources. So in TMF terms, one could say this is about managing RFSs, resource-facing services, roughly. The management domain exposes management services towards external consumers. These could be other management domains. These could be the end-to-end service management domain. And by doing so, it also encapsulates internal details. So the interfaces, ideally, should not change if you change the realization inside the domain. Yeah, and as I said, there can be composition, so a management domain can consume management services from other domains that you would typically do if the actual service that you're managing is also composed from other services, from other domains. For instance, you could have some connectivity service, fixed line connectivity service, and you could have a failover to mobile. Then you would consume the services from some kind of mobile domain for that failover. The other scope of management is the end-to-end service management domain. It manages end-to-end services that span multiple management domains. Again, it exposes those services towards the digital storefront, and it also coordinates between those domains. The next feature is that our architecture is service-based. So what we're defining are management services that are exposed by management domains, and we have a specific term for, well, the entity that we use to realize the service exposure. We call that entity an integration fabric. An integration fabric provides services which allow us to expose, to consume, to register management services. It has basically three big areas of functionality. The first one is the management data transport. Management data transport is responsible for the transport of streaming data across the domains, also inside the domain, but more importantly across domains. In implementation terms, you could think of a Kafka bus here. The idea is to be able to provide information about events that occur in the system rapidly to all authorized subscribers that may have an interest in such event. The next big functionality group is management service exposure. It allows to publish services, to discover them, to consume them, and it could be, well, an implementation could be an API gateway, for instance. And the third big group of services are control services. These are needed to parameterize, to steer the two other big groups of services to just ensure that everything works right. One important item is authorization and access control. So it's necessary to ensure that only authorized consumers can have access to the management services. Other functionalities are about keeping the system performing, such as applying throttling to ensure that there's no overload situation and so on. We have decided to define some indicative groups of these management services. This is work in progress, and the intent here is to basically, allow the notion of closed loops. So it's a kind of classification of the services. So we start with domain assurance, or what we call currently domain assurance. These services are responsible for monitoring the managed entities. These could be resources, this could be services consumed from other domains, and to provide live updates about the performance and any faults that may happen. Such information may be interesting for functional components that provide, for instance, domain intelligence services, so that derive from this information decisions and recommendations. Based on these decisions and recommendations, as a next step, there is the need to make a plan to basically change something in the network to fulfill those decisions that were made, or those recommendations that were made. Such services are orchestration services. These automate workflows and processes. These processes, for instance, handle instantiation, they handle lifecycle management of the services provided by the domain. They can also be needed to coordinate certain actions that you do when you configure resources. Sometimes you have to configure something before something else. So this is, these are examples where you would execute workflows. And last but not least, we have domain control services. These are services that act directly on the resources of the domain, that can change parameters, that can install software, and so on. Here we see the current status of the list of services that we have specified so far. Many more are in the pipe, and we're basically just needing to get the set right and also the parameters. As I said, this is work in progress. Let's start here with the services that monitor resources. We have services that provide fault events, security events. We have anomaly detection services. We have also simple analytics services. And in discussion, we still have the whole bunch of performance monitoring, which is upcoming. Intelligence services, hopefully I can report next time what we do there. This is currently work in progress. Orchestration, we just have an orchestration service here currently, but there's more to come. For domain control, we have configuration management, and also here there's more under discussion. Furthermore, we have some kind of general services that are needed throughout the loops. This is policy management. Of course, everything is controlled by policy. We have configuration generation. That is something we put here. There will be probably some reassignment in the future. Right, the next important feature are common data services. I said it already, data can be considered the lifeblood of automation. Without information about what's going on in the system, automation will not work. We already saw that we have data streaming. This is part of the integration fabric, and this allows to inform the components of things that are going on. So components pick up those events and then can provide their services based on that. But there may be the need for more. There's also the need for persistency. So for persistent storage of data, this is done by the common data services. These are logically, well, how can I say? They're logically common. So physically, they may be distributed, but they can be accessed like one big common service. The responsibility of that service is mainly the storage of management data and the sharing of these data with authorized consumers. These consumers can be in the same domain or they can be in other domains. Also, we're discussing about other use cases such as supporting big data analysis directly on the stored data. But this is currently under discussion. And one thing that is very important is that the data are provided rapidly to the consuming components. Otherwise, again, they will slow down the execution of the control loop. Well, and one more architecture feature. This is the enablement of closed automation loops. One possible classification scheme for this is called OODA, Observe, Orient, Decide, Act. And this allows to build closed automation loops. We first start with an observation. So there need to be components in the system that monitor the network resources and that provide services to communicate the information that is basically obtained here. This could be a time series of measurements, This could be a threshold crossing event. This could be fault event. So if something interesting happens in the network, this needs to be communicated by services that observe the network. The data could be stored in common data services. The data could be stored in databases that are optimized for big data. The data could be just communicated to any component that would be interested in picking it up. But in general, what these would lead to is some kind of analysis or some kind of prediction. This now starts the orientation part. So the results of this would be picked up by some intelligence that would create recommendations. Recommendations can be used to resolve intent. Recommendations can be created by evaluating policy rules. Recommendations can be disambiguated using policy rules. But last but not least, we need to make a decision what to do. And once that has been decided, we need to orchestrate change in the network. That means we need to coordinate changes to different parts in the network. This could include bringing up new instances of VNFs, for instance, if we have NFV technology deployed. This could mean that we have to coordinate configuration actions to the network. And eventually, these actions need to be executed on the network resources. And then the whole loop starts again with observing change and checking if the change went to the correct direction. So if we want to decrease the load and we add capacity, then we observe the load. And if the load goes down, fine. If the load goes further up, well, there's the need to do more or something else. Yeah, here's a very concrete example that we looked at when we were developing our use cases and requirements in ETSI ZSM. Assume there is a fault that some gateway is not responding. This fault event is picked up by a monitoring component and is shared by a service that reports fault events via the management data transport in the integration fabric. So this information is published and it is picked up by components that have subscribed to this event. In this example, we have an analytics component that has subscribed to it, and also the common data service has subscribed. No, the domain data service has subscribed, so it's stored in the data service inside the domain. Then the intelligence component starts to figure out what might be the root cause, determines that one link to the gateway is bad. It here in this case, because there is no orchestration between different actions, it's a simplified example, it can basically consume directly the configure resource service. This is provided, of course, by some piece of software. And that piece of software receives the request via the integration fabric, and it basically changes the configuration of a router so that the traffic to the gateway is now taking another path. And then some component here would observe that there is no issue any longer. Okay, that were basically the main features that we built into the architecture so far. I already said this is work in progress, and I have been presenting to you the current status of this work. This presentation is based also on a specification ZSM 002 in ETSI. You can always track the progress here at that URI. We make publish any draft that we develop. Next steps in this work, based on where we stand, is to first complete the definition of the services exposed by a management domain. You remember this picture where there were many lollipops saying more to come, in progress. So this is what we're currently working on. Then we have to do the same for the end-to-end service management domain. We have to define the services that this domain exposes towards the digital storefront. And once this is done, we have basically laid the foundation for doing closed automation loops. So I presented some ideas. These are initial ideas, subject to evolve. This is then the next big step that we have to take, define how we support closed loops in the ZSM architecture. To conclude, the ZSM Framework Architecture is flexible and service-based. It separates the concerns of managing network domains and managing end-to-end services. And it includes two key entities that provide flexibility to integrate services and to integrate data. These are called Integration Fabric and Common Data Services. And by providing this flexibility, we also have built a foundation that enables us to execute closed loops on these services. Okay, thank you for your interest and attention. And I think we have a few minutes for Q&A before the break starts. There will be a mic be coming.
Tim DeWerin at ACG Research. My question was going to be thinking about the common data stores. You can see a scenario where there's some type of analysis that's okay happening, I'll call it slow and in the background, analyzing trends or something like that, and just would not need rapid memory access. There's other things you'd want to be real-time or near real-time. And so what I was thinking about was, do you kind of have classes of memory stores, or is there how do you deal with the fact that maybe some exposure of data would need to be fast versus other exposure of data would need to be slow? Thanks.
Well, you bring up a very good point, and in fact we have a requirement for that, saying we have to support different velocities here. We are not yet at the stage to define this in detail in the architecture. So for the time being, we have captured this as a requirement. And indeed, I mean, it's also a dimensioning issue, right? If you have a database and you require the highest service category for all the consumers, you end up with a very big machine that turns out to be very expensive, and it may not be necessary. So yes, this is a very valid point, and we will consider it in the design.
Yeah, I'm Mark Cohn, by the way. I was wondering, and this actually is a question for you and Diego, since Diego thinks we ignored him. Can you talk about the touch points and the interactions between this architecture and the ETSI NFV architectural framework?
Yeah, this is also a valid question. I think we will see some items that we have in NFV. We will see here in a deployment of the ZSM architecture framework, right? So there may be other deployments possible. The idea is that this is flexible framework, but I would, for instance, see a generic VNFM as we have defined it in ETSI NFV. I could see it. Let's just find the picture. I could see it here, right? So creating a cloud resource is basically a task that could be done by a generic VNFM that is included here. Some others may see it here. However, I think the fact is that the generic VNFM would have access to the resource layer, because it has to manage cloud resources. It has to talk to the Vim. Well, NFVO could be seen here. So, or parts of the NFVO. Some of the orchestration functionalities that an NFVO does could be seen in domain orchestration. But I mean, what you're touching is a point where discussion has already started, or only just started in ZSM. So we have no ready-made answer. So therefore, I was now bringing forward my personal view. Even other people that are active in ZSM may have other views on how to do that. I wouldn't be surprised. So this is work in progress and needs to be addressed. I was just sharing some possible solution ideas, and we will have to find consensus on something that we all agree. Like,
yes, just to illustrate that there is no consensus yet. I disagree with what Uwe was saying. No, seriously, just the point is that there are some aspects that are precisely open right now. In particular, that there are terms there that are being discussed, whether we should use, and it's something that I am really concerned whether we should use the terms of orchestration and control in this context, because they can be a little bit misleading. And this is something that we are discussing, and precisely this, whether you need a VNFM, or we're talking about something that is talking to the northbound interface of the NFVO, etc. So it's something that still is a little bit open, and well, it depends as well on something that I try to insist very much. The NFV architecture is a framework. It's not necessarily, it has only not necessarily a one single realization. And this is important as well, because you would place, or you could place components in different, in different positions. The important thing in my view here is about the interfaces. Which are the interfaces that should be used, and which are the models, I mean the data models that should, or not the data objects that should be exchanged through those interfaces. Whether you're talking with a particular piece of the NFV or another is something that I would think is more a matter of the design rather than the architecture.
Just one observation, maybe Klaus and Diego or the groups get together and have something, maybe a slide or two that has a mapping so that we have something to go on, as opposed to ambiguous terminology between the groups that are admittedly used in the appropriate context, but it's still confusing when you're an outside observer trying to look in.
Okay, I think this good discussion gives you a good idea which spirit you have. We are not always on the same page if we're starting a discussion, we can imagine that. But I'm really happy to say that we have this good discussion internally in this group, and as we said a couple of times, you are invited to join us and to support us in the discussion. It's not always simple, but it's very interesting work. You see the status we have achieved so far. It's not that bad considering the time which we have spent on this ISG since we are. But Uwe, thank you for his good explanation.
Welcome.
I learned also a lot again.
Yeah. So first of all, thank you very much, and thank you also for the good questions in place. Again, I want to mention this is architectural framework, okay? The intention is to have it very flexible, to allow different solutions to be incorporated, and we need to differentiate between the architectural framework and the solutions, right? In the solutions, we will definitely leverage available solutions. So for example, available APIs from NFV, in available solutions from SA5, maybe available solutions from ONAP or whatever. So we need to differentiate between the framework, which is trying to be something that shows that can enable the transformation to digital, the digital transformation, and the solutions that we want later on to be leveraged for that, okay? So we need to be very careful not to tie ourselves to a specific solution when we're designing the framework. We need to ensure that the framework is a good framework that can enable and satisfy the different scenarios that we see, and can satisfy every future scenario in its flexibility way. So this is a very important discussion. I believe it will come definitely when we come to the gaps and the solutions. Okay.